Okay, so now in this example, we're going to get the Maclaurin series. Okay, so we're going to use this function. We're going to do some other examples too of this, but we're going to start with this function here, e to the x, and we're going to want to find the first three Maclaurin polynomials. Okay, we're also going to represent this using summation notation as well. Okay, because we want to find what the nth term looks like and then represent it as a summation. Okay, so let's start. Okay, now remember, Maclaurin series is a Taylor series that is centered at 0, where x equals a. Okay? Or excuse me, when x equals 0. So, or excuse me, a equals 0. Or x equals a, same thing. Or no, I'm sorry, when a equals 0. So, how do we do this? Well, first of all, actually turns out to be very straightforward, because we know f of x is equal to f prime of x, which is equal to f double prime of x, which equals f the nth prime of x, which equals e to the x, because the derivative of e to the x is e to the x. Okay? Which means that f of 0 equals f prime of 0, which equals f double prime of 0, which equals f to the nth derivative, the nth derivative of f of x, of f of 0 rather, is equal to e to the 0, which equals 1. Okay, so that makes things pretty easy to deal with. So now we want P0 of x. Okay, so P0 of x is equal to f of 0, which equals 1. And then P1 of x equals f of 0 plus f prime of 0, right? Times x minus 0, right? Which is just x. And so, what is this going to equal? Well, this is going to equal 1 plus x. And then p sub 2 of x is going to equal f of 0 plus f prime of 0 times x plus f double prime of 0 over 2 factorial times x squared. Well, this is just going to be 1 plus x, right? This first part is just going to be 1 plus x. And then this term here becomes what? Well, this is just 1, right? It's all 1, so it's going to be 1 over 2 factorial, which is 1/2. So it's going to be 1/2 x squared. And then P3 of x equals what? Well, again, I'm just going to repeat these three, right? It's going to be the same 3, but so it's going to be 1 plus x plus 1/2 x squared. But then the next term is going to be what? It's going to be f triple prime of 0 over 3 factorial times x to the third. Well, this is just going to be 1 over 3 factorial, which is 6, 1 over 6, so it's going to be 1/6 x to the third. So 1/6 x to the third. Okay, now, the next thing we want to do is we want to find the nth term, the formula. We want to find a formula for the nth Maclaurin polynomial. Okay, and we want to write it in sigma notation. Okay, so what's going to happen with p to the n? If we are not p to the n, p sub n of x. Well, it's going to have the same sort of pattern here. Okay? So we have 1 plus x plus 1 half x squared plus 1/6 x to the third plus dot dot dot. And so the nth term is going to be what? It's going to be 1 over n factorial x to the nth power. Okay? And so if we do that, if n is 0, we get 0 factorial, which is 1. So we get 1 over 1, which is 1. And then we get x to the 0, which is 1. And we get 1. If n is 1, we get 1. And we get x to the 1 power, which is x. When n is 2, we get 1 over 2 factorial, which is 1/2 x squared. And so on. So we can represent the nth polynomial then by just using summation notation, sigma notation. So this is going to be n equals 0 to infinity, or excuse me, to n. How do I want to do this? N equals let's do capital N, because I'm not sure. Or no, you know what? Let's change the index. Let's use K. Okay? And to N like that. Because then, okay. So P sub N of X is going to be the summation from K equals 0 to N of what? Of, in this case, then we would use K. So it'd be 1 over K factorial X to the K. Okay. Or if you want to write it all as one fraction, that's fine. So it'd be the summation from n equals 1 to 0, or excuse me, from 0 to k, not n. K equals 0 to n of x to the k divided by k factorial. So we could write it that way as well. Okay? Okay, and that's it. We'll come back and we'll do another one just like it.